All right, hello everybody. Here's our video on the examples of the probability questions that I was telling you guys about. So let's go ahead and jump right into that. So something that I want to stress to you, I can never open this, there we go, is that you have to be very careful when you read the problem. Oftentimes there are little words in your question that are going to kind of frame the way that you think about the situation. The way that the question is framed will determine your approach. Okay, so you really do have to read very carefully. Reading comprehension here is an essential skill when actually doing this probability stuff. So first example here. Suppose you are choosing a random student from the hallways. If P of senior is 0.32, what is the probability of not selecting a senior? So we're saying the event of choosing a senior has a probability of 0.32, 32%. What is the probability of not selecting a senior? So just as a quick picture, okay, here's our big sample space. This is the event of choosing a senior, so that's 0.32, and the space that we are looking for is all of this stuff on the outside that is not a senior. So being a senior is 0.32, we want all this stuff that is not a senior. So since the probability of being a senior is 0.32, that means that the complement of that is going to be 1 minus 0.32, so therefore 0.68 is our solution. So the probability of not selecting a senior here is 0.68 because we're using the complement rule directly. Okay. Next example. You now need to choose a student from the hallways once per day. What are the chances of choosing a senior 2 days in a row? So, again, let's look at the way that this is framed. We're making two choices. We're choosing 2 times, and we're saying, what's the probability that we get 2 days of seniors in a row? In other words, we're looking at what's the probability of choosing a senior and a senior, right? Making 2 choices, we're looking for P of senior and senior. So, choosing a senior on Monday is independent of choosing a senior on Tuesday, okay? The 2 events will not affect each other. Therefore, they are independent events. And the probability of Monday senior and Tuesday senior, or senior and senior, is using our multiplication rule, probability of choosing a senior times probability of choosing a senior, which is 0.32 times 0.32, or 0.1024. So there's we could draw a picture of this. We'd have to figure out all of our outcomes. In this case, our outcomes are senior and senior, senior and not senior, senior and not senior and not senior, and then not senior and senior. So we've got 4 different outcomes, and the picture on this one's actually kind of boring because are any of these outcomes mutually exclusive? Can I pick a senior and a senior and not a senior at the same time? No, you can't. So this one is just 4 circles inside of our sample space because that's the only things that could happen. And there's no overlap between them. Okay. Next example. So suppose P of senior equals 0.32 and P of junior equals 0.36. What is the probability that a randomly selected student is a junior or a senior? So let's look at some keywords. We're looking for a randomly selected student that is a junior or a senior. Reading that or statement in there tells me that automatically I'm going to have a probability with an or statement. In this case, probability of junior or senior. Are these two events mutually exclusive? Can I be both a junior or a senior at the same time? No, we can't. We can't be a junior or at the same time, so they're disjoint, mutually exclusive, same thing. Which means we can use the addition rule to solve this. P of senior or junior, that's 0.32 plus 0.36 equals 0.68. So there's a 0.68 chance of choosing a junior or a senior because they are disjoint events. Next example. Suppose P of senior is 0.32, P of junior is 0.25, and P of sophomore is 0.21. What is the probability the randomly selected student is a freshman? So notice we don't have the information about a freshman up there. So we've got to look at our the information given and frame this in the appropriate way. We know that there's 4 different options, or we're going to assume that there's 4 different options: senior, junior, sophomore, and freshman. And if I'm going to give myself probabilities for each of those things, I know it's 0.32, 0.25, and 0.21. This is the one that we're trying to find. Now, we can use a couple of different pieces of information to solve this. First of all, we know that the events are disjoint. Seniors, juniors, sophomores, freshmen can't be those at the same time. So we're going to be using the addition rule to do this. In addition to this, we know that all 4 of these distributions up here. Whoa, what just happened? Whoa, hey, get back. Where were you? There we go. We know. Stop it. Hey, look at that. We know that these 4 probabilities need to add up to be 1. So if I were to add these 3 things together, P of senior, P of junior, P of sophomore, senior or junior or sophomore, and then find the complement of that, because P of freshman is going to be the same thing as P of senior or junior or sophomore complement, right? These 2 things are exactly the same. So if I find P of senior or junior or sophomore and subtract 1 from that, 1 minus 0.32 minus 0.25 minus 0.21, I get 0.22. That's what that has to be. Because P of freshman is the same thing as, and I wrote that there, I just wrote it here because it's easier to see, is the same thing as P of senior or junior or sophomore complement. So it's just 1 minus whatever that probability is, whatever this probability is. So again, it's all about the framing of the question, and you can use some of these rules to be flexible in how you find the numbers. But you've got to read the question appropriately. I've got a couple more here. What is the probability of not choosing a senior until Thursday? Okay, so we got to think about what this situation is telling us. We need to not get a senior on Monday, Tuesday, and Wednesday. In order to choose a senior until Thursday, I have to not get one on Monday, Tuesday, or Wednesday. So what we're looking for here is P of senior complement and senior complement and senior complement, right? I have to have 3, and actually no, I need to add something else onto that, because the last one needs to be and senior, because I have to go Monday, Tuesday, Wednesday, no senior, senior Thursday. So, let's see, did I put that information? Yeah, so I said that right there. For this to happen, you need to not choose a senior Monday, Tuesday, Wednesday. Therefore, P of not senior is 0.68. So we're going to have not senior, not senior, not senior, senior, which is 0.68. Oh, maybe I put it on the slide. I should just hit the button. Yeah, which is 0.68 times 0.68 times 0.68. 3 not seniors in a row, and then a senior, 0.101. Uh, so again, question framing. What's the only result that can make this happen? And again, these are all independent events. Not having a senior on Monday is not affecting not having a senior on Tuesday, which is why we're using the multiplication rule to solve this. And again, the only way to make no seniors until Thursday would be to have no senior, no senior, no senior. No seniors in a row, and then senior on Thursday. Okay, what else? That's the next one. What is the probability of choosing at least one senior throughout the week? Ooh, okay, so that one is a little bit trickier because this phrase right here, at least one, what is the probability of choosing at least one senior throughout the week? Okay, so how do we frame that one in terms of the probability? How do we make it so that we have at least one senior? Okay. Well, at least one senior means I would need to choose a senior 1, 2, 3, 4, or 5 times. Like there's a lot of different ways that I can choose a senior. If we wanted to talk about this, like there's 5 different spots, each representing a day of the week. I would need them to have the number of situations where, or let me try this one more time. I would need to think of every situation where I would be choosing at least one senior. So here I chose 3 seniors. So that's a lot of different ways to do it, right? Because I could have no senior, no senior, no senior, no senior, senior. I could have no senior, no senior, no senior, senior, senior. Or I could have any of those mixed around in between. So trying to count up the number of ways to choose at least one of these would take a really long time. However, we can use knowledge of the complement because there's only one result which doesn't have at least one senior. What's the one result that doesn't have at least one senior? Well, the only way that we can have no seniors. Why do you do this to me? The only result that would result in there being no seniors is if we got senior complement, senior complement, senior complement, senior complement, senior complement. That's the only way that we won't have at least one senior. Which means if I want to find the probability of having at least one senior, I can take this probability and use the complement rule to figure that out. So P of choosing a senior at least once in the week is going to be 1 minus P of not choosing a senior at all this week. The complement of having at least one is 1 minus having none. So P of not senior, not senior, not senior, not senior, not senior is 0.68, 0.68, 0.68, 0.68, 0.68, right? Because that's the probability of not choosing a senior, which is 0.1 minus 0.68 to the 5th power, which is 0.854. And apparently it's 0.854 because we have 2 decimal points. No, it doesn't mean anything. So at least we gotta be really flexible with the way we think about that. At least one, the only way we can really find that is finding the complement of none. If we were to try to do this by looking for all of these combinations that we could get that had at least one, we'd be making a list for a long time. It would not be worth it when we can use the complement rule to find it. I think that's all my examples. So the phrase at least is often a tip-off to think about the complement. Okay? Keep that in mind. Something that happens at least once does happen. Happening at least once is the complement of not happening at all, and that's easier to find. A couple other keywords here. Not typically means subtract from 1, right? Not typically means complement. Not like, hey, you look nice today. But the opposite, right? Subtract from 1, complement. Or typically means use the addition rule, and typically means use the multiplication rule. And the really tricky, fun thing is that I can write a problem that has all three, right? There's ways that we can write, and you will see problems that uses the words not, or, and, add, and that's telling you how you're supposed to mix up the addition, multiplication, and all of those things within a problem. So we'll get to some of those more complicated things next week. Keep in mind the notation here, and that is what I got for you. If you've got questions, you can ask them on the Facebook page or on Google Classroom, and I'll do my best to get to you. Okay, see you.